Hi, my name is Tyler Turner, and this is my video lab for Physics 2 Lab Number 1. Let's start with an introduction and overview of the lab and the experiment itself. The purpose of the lab was to observe the behaviors of our materials in the experiment, as well as to measure the amount of excess charge as a result of the interaction. We were required several materials to conduct this lab correctly. The first was that we needed 2 cups. Second, Scotch tape. Third, measuring tape to measure the distances, including the lengths and the widths of the tape. Finally, a pen, flat table, as well as access to GlowScript in order to make sure our calculations function correctly according to the programs that we create later in the lab. First of all, to summarize the findings that I found in this lab experiment, the first was that the tapes ended up repelling one another, which we will get to later in the lab to explain why. And second, the amount of excess charge was found to be 1.15 times 10 to the 10th electrons. There are a few fundamental principles that we've learned thus far in Physics 2 that were key in order to understanding and implementing the lab. The first is that of the force of gravity, in which force is measured by the mass of the object as well as g, which is 9.8 meters per second squared, the gravity force of the Earth, the gravity speed of the Earth. Next is Coulomb's law, which is going to find the actual force between two charged particles, which is equal to k, 1 over 4 pi epsilon, times the first charge times the second charge divided by the distance between them, r squared. The third key principle is that of an electric field, which is measured in coulombs, which is going to be k times the charge of the object times the vector of r divided by the distance, r squared. The experiment data was collected via measuring the actual tape that was used and, finding out all these information with the tape. First, the distance, which is tape A and tape B, which was determined to be 0.005 meters. Second, the length of tape B was determined to be 0.2 meters. The width of tape B was determined to be 0.02 meters, and the mass of tape B was measured to be 1.99 times 10 to the negative fourth kilograms. There were a few key assumptions that I needed to have in order to, have consistency with the actual results. And the first is that we are considering that there's equal charge on both tapes before the beginning of the experiment, and that both charges are relatively in the middle of the both tapes are considered to be equal. Another assumption to note is that the mathematical formations will be correct, including the GlowScript code, as well as the ones that I, figured out in the lab with my calculations. And the third is that error will not significantly change the result. That includes human error, the formulas and data that we were given in the lab instructions, etc. So the first step that I did after collecting this data was to calculate the magnitude of charge in the experiment, the first being mg, which again is mass times 9.8 meters per second squared, which I determined to be 1.5 times 10 to the negative 3 newtons. I was then able to set this force equal to the one provided by Coulomb's law, which again results in 1.86 times 10 to the negative 9 coulombs. The next step was to find the number of electrons on tape B, which is, again, at the top, which gave us the number of excess. Next was to find the number of atoms, which was the tape area over the atom area, which is in the middle, as you can see, those calculations right there. And finally, in order to find the electrons to atoms ratio, divided the number of excess electrons by the number of the atoms, which gave me this number of 2.9 times 10 to the negative 6 electrons per each atom. Finally, there were two key questions that we had to ask ourselves and sort of explain in the lab. The first is, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? The answer to this is absolutely nothing, because a proton is not necessarily inherently negatively or positively charged. We as humans, have created the system of just identifying electrons as negative and protons as positive. So just switching the signs would not change anything. It would still be the same. The second question is, why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes come into contact with your hands or other objects? It's important to handle them because we don't want any free electrons, impacting the charge from our hands or our clothing if they are, interacted with too much. So those are the findings of the experiment. Thank you.